All right. Good morning. Hello. We are Team 18, and our project this year was porting the IronClad kernel from x86 architecture to RISC-V architecture. And it was a very interesting and fulfilling project. I think everybody in our team enjoyed it. Um,
Definitely.
Yeah, so we can start with a quick demo. So actually, before we get into the demo, it took a while for us to discover our end users. So what we ended up deciding is that our end users are going to be developers that were porting this kernel to RISC-V architecture to get a lot of functionality out of it. We ported the majority of the libraries, and we were able to get it to boot to an idle state. That was sort of the objectives and the outcomes of our project. But we also recognize that our end users are the developers, and we want to provide a clear and comprehensive product for them because, as I'm sure everybody's aware, documentation systems, automation and tools can kind of be lacking, and workflows can kind of be lacking for open source projects, especially with open source simulation via QEMU on, which is what we use to simulate our product, and the RISC-V, simulating RISC-V in QEMU, developing Ada code on its own. So what we did was we developed a few automation scripts. So where you can see we have build and run, we have install, run with no graphics or run headless, run single core, and then simultaneous multiprocessor running with a multi-core configuration. And so the install script, I'm not going to run it because it does take several hours, but this has been confirmed. This bash script installs all appropriate packages, identifies the package manager of the Linux distribution. So this can be run on a Debian or an Arch or Red Hat based Linux, although it has only been tested on a Debian based Linux on Ubuntu. But it installs all the required packages, clones the QEMU source code because we recognize that that had to run without we had to clone and build it locally. The version distributed via the package manager does not support RISC-V emulation simulation. And then we clone our source code, and then we build IronClad and the operating system on top of it, GLAR, into a ISO, and then run it initially. So that installs all the tools and runs it for the first time. And then anytime somebody wants to modify the code afterwards, they would run build and run. So we can run that right now. So build and run is going to rebuild the IronClad kernel, and then it's going to interface it with the packages for the GLAR operating system on top. And then once it is done building, it will initialize the emulation. This is going to start, and then it boots into an idle state. It's a little bit boring now because they're not interactive anymore. However, we can see that it loaded the bootloader via the OpenSBI. It identified memory that's available in different ports that are hard coded to the simulation hardware. Um, Loads the firmware, and then LimeMine is the name of the firmware that is used. And then we do a bunch of processes during the initialization and booting. We identify the memory maps, we print what's available. Currently, we are failing to mount a root volume. And then we enter userland and go idle. So that's our project. Very exciting. If you have any questions, please let us know. And thank you for your time.
Thank you.